For 2 years, we've interacted with AI through chat interfaces. We provide a prompt, and the model returns a string of characters. But those characters remain trapped inside the window. They cannot move a file, edit a document, or interact with a local server on their own. This is because standard API connections to these models are essentially stateless sandboxes. They are designed to process information in isolation, leaving them incapable of executing actions within your specific local environment. This void is the execution gap, the distance between an AI generating a plan and a machine applying it. Openclaw's latest release acts as a multi-layered middleware stack to fill this gap, creating a physical connection between the model's logic and the local hardware. Deploying AI in a professional context requires a shift in focus from the prompt window to the execution environment, establishing a persistent layer for genuine local machine autonomy. This architecture functions as an AI operating system, a layer of software that sits directly between external third-party models and your local files. Unlike previous experimental frameworks that relied on a web of manual external scripts to bridge this gap, this system integrates execution directly into the core. The update organizes this infrastructure into 4 foundational pillars. First, native I/O capabilities. Second, deep system extensibility. Third, enhanced system resilience. And finally, intelligent routing. When these pillars are in place, the developer's responsibility moves away from simply generating text and toward managing the security and operational permissions of the entire system. Transitioning from a stateless experiment to a stateful operating system is the prerequisite for scaling autonomous business workflows. Early autonomous agents were severely limited by their inability to interact with local assets. Without direct access, tasks like editing a spreadsheet or organizing a directory required cumbersome, error-prone workarounds. In the new I/O layer, data packets stream seamlessly from the central Openclaw hub into local directory folders. Built-in fetching and writing protocols allow an agent to retrieve a file, process its contents, and deposit a modified version back into the grid. The update also adds native directory listing, allowing the agent to map out and understand the structure of your local folders automatically. Because these operations are native to the platform, they bypass the latency and complexity of external scripts, resulting in much faster execution. Native file access provides the AI with the ability to manipulate data physically. It transforms text generation into a tool for direct workflow manipulation. Above the file system sits the extensibility layer. For an AI to perform specialized tasks like query in a database, it must interact with a variety of external plugins. In the past, this was a major point of failure. Broken packages and conflicting software dependencies caused these systems to crash frequently during operation. Openclaw restructured its plugin ecosystem, organizing a chaotic web into a clean, hierarchical tree. Automated processes now resolve dependency conflicts during installation. Refined update protocols allow individual components to be upgraded to newer versions without disrupting the rest of a system. For components that are beyond repair or outdated, the system now includes failsafes to quarantine those specific packages. These stabilization efforts directly increase the reliability of complex agents that must use multiple tools to complete a single task. Scaling production projects is only feasible when the underlying ecosystem can guarantee that its dependencies remain stable under load. Because AI systems are inherently non-deterministic, they will occasionally produce unexpected outputs or encounter errors. This is a basic reality of the technology. To manage this, Openclaw has implemented resilient update handling to isolate errors and prevent a single failure from crashing the entire machine. This includes configuration repair tools that can automatically fix corrupted settings that might otherwise require manual troubleshooting. This diagram shows the plugin state recovery mechanism. When a component crashes, the system instantly bypasses the failed component, resets its state, and restores the data flow without stopping the rest of the workflow. Automating these recovery steps reduces total system downtime and lessens the burden of manual maintenance for developers. The presence of autonomous self-healing is what distinguishes a reliable production-grade deployment from a fragile developer experiment. The final layer of the stack is routing. This is where Openclaw acts as the central hub for all outgoing communication. The update includes architectural changes that ensure more reliable message delivery across different network protocols. This specifically improves how the system integrates with communication platforms like Discord, Slack, and Telegram. It is important to remember that Openclaw still relies on external models, like those from OpenAI or Anthropic. This creates a permanent dependency on those third-party providers and their pricing structures. However, with the full stack active, Openclaw serves as a universal router, converting external intelligence into synchronized business actions across multiple channels. This level of control has led many to describe Openclaw as the Linux of AI. It provides immense flexibility, but it is technically demanding and not intended for casual users. This diagram maps the primary trade-off. Increasing an agent's automation capability with native file access expands the attack surface of your local machine. Third-party plugins are a specific risk. If unvetted, they introduce vulnerabilities directly into the operating system's core. Even without malicious intent, a simple configuration error can lead to the accidental exposure of sensitive local data. There is also the threat of malicious extensions that could weaponize the agent's file access to steal credentials or damage the system. Because the platform is evolving quickly, updates often include structural changes that can break existing setups, requiring constant monitoring from engineering teams. True autonomy is a double-edged sword. The features that make powerful execution possible are the same features that scale the risk of a system-wide compromise. For those deploying this system, a strict auditing protocol is essential. You must remove any unused extensions and manually verify the security of every plugin you use. Never deploy a version upgrade directly to a live environment. Test all updates in a separate sandbox to ensure that breaking changes don't disrupt your operations. Use the new recovery tools to conduct routine health checks, ensuring the system remains stable over time. Security requires strict isolation. Always limit the permissions granted to the agent, and run your workflows exclusively within containerized environments to protect your host machine. When managed with these precautions, Openclaw is an effective tool for custom business automation and complex multi-channel workflows. This release provides the foundational architecture for the next generation of digital business. It offers a path to genuine AI autonomy, but only for those who can match its